that was, by the way, wrong, and I've corrected it at least 3 times this week. If you know sigma, then you know that the standard deviation, the standardized test statistic is in fact normally distributed, and you use a z. Okay? That was incorrect in the slides you had. If you don't, if you do know the parent population is normally distributed, then you have a ratio of 2 random variables, and that injects more uncertainty, which is captured by the t distribution, which is what we saw last week as well. There are basically 2 scenarios, one-sided and two-sided. Both of these had to have the inequality, right, in the null, just as with the large sample hypotheses. The only difference now is instead of z, we now have t. And we have t with n-1 degrees of freedom. But that's really the only other difference. The problem, though, is if I ask you to find a p-value, you're going to have it double the time. And we'll look at an example when we get to the problem. The difficulty lies in the table. The table only gives you 1 row, right, for n-1 degrees of freedom. 1 row compared to an entire table for the z distribution. And that's the reason why you can't get very precise answers using the t distribution. We'll show you how that works, but note the last sentence. That's not crucial for what we're going to deal with. I will either give you the p-value, or I might ask you for a range, but that'll be more like the hardest thing that we do. It really is not critical. Interpretation, however, is. So let's just wrap this up before we do a problem on a small sample confidence interval. I'm sorry, hypothesis test for means. If this is not on your crib sheet for the final, either it or something similar should be. First, remember, you ask if you're dealing with a research or a managerial hypothesis test. But once you get to that point, you ask yourself, are you dealing with a mean or a proportion? If you're dealing with a mean, the third question is, what's your sample size? And you have to remember the magic number of 30. If you have more than 30 observations, everything else pretty much follows. It doesn't matter if sigma is known, because if it is, use the standardized test statistic. If it's not, then you just estimate sigma and you get the exact same standardized test statistic. So life is good if you have more than 30 observations. It's a little more tricky if you don't have 30 observations. Then you have to ask yourself, is your parent population normally distributed, at least approximately? If the answer is no, at least life gets simple again, because you have to go get more data. So just as a check, if on the test you get the question, you have 22 observations, blah, 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 can you, test this hypothesis? But nowhere is it stated that the parent population is mound-shaped, bell-shaped, symmetrical, normal, anything like that. What's the correct answer?
Go get more data.
Get more data.
Get more data. Good. If you do know that the parent population is normally distributed and sigma is known, then you're back in the good old territory of a z. Only if you don't know sigma, you have to estimate sigma using s, and remember the parent population is normal, can you use a t? It's a very particular animal. Okay, so how does a t work in real life? Well, to illustrate that, we're going to do our second problem of the day, problem 67. In problem 67, we have 10 firms that have mean earnings per share for 2001. So n is equal to 10, and we're going to assume that x is normally distributed with some mean and some standard deviation. Note that that is not stated explicitly anywhere other than right here. So I freely admit that I put a greater emphasis on checking your assumptions than this text is doing right there. Okay, so we've got 10 firms, and we've got data, excuse me, which give us an x bar, so 1.92 plus all the way up to 2.38 over 10, which gives us roughly 2.8. And S, which I'm just going to report, be calculated in the traditional way of 0.70. In addition, we were told that in 2000, so the mean in 2000 was $3. I don't know what's wrong with this jacket, it keeps folding wrong. Okay, formulate the null and alternative hypotheses that can be used to determine whether the population mean earnings per share in 2001 differed from the $3 reported in 2000. What's the key word here? Differ. And so, the null hypothesis?
Is equal.
Very good. So the null is that mu is equal to mu sub 2000, which is 3. And therefore the alternative is what?
Not equal.
Very good. Any questions on that? Okay, I need to remove some stuff. All right, just as an innovation, we'll now move towards the left. So, under the null hypothesis, the distribution of the standardized test statistic, which is x bar minus mu sub 2000 over s divided by the square root of n, is distributed how? Not normal, looks normal, but it's not. Has fatter tails. This is under the null hypothesis. It's going to be distributed with a mean of 0. It's not normal, it's not z. The only other thing we've looked at is t. And how many degrees of freedom? Not 2. 9. Why? And minus 1. Very good. So this is t distributed with degrees of freedom equal to 9. We are further, actually in E, we're asked to use an alpha of 5%, which means that we're going to come up with half of alpha on each side. And how much is a half of alpha? 2.5%. Good. Everybody happy with that? What's the next step? This is the first step. It's step 2.
Find the relevant range.
Fine.
Relevant range?
I think you said I just couldn't
The
hear it.
relevant range?
Not relevant, but rejection rate.
Oh, the
Yes, but RR, yes. And in order to do that, we have to ask ourselves, well, how do we do it? We look up 0.025 in which table? T, and what do we find? How much?
2.262.
There we go, 2.262. Everybody see that? Haven't? Okay, we need to look at the right table. T table? Alright. 0.025. Freedom. Alright, everybody happy with that? Yes.
Do you know where?
Okay, you have your book with you?
Yeah. All right.
But it's 9 degrees of freedom.
Oh, 9 degrees.
Because the tail is 2.5%.
Exactly.
All right, everybody else saw that? Should I put it on the doc cam? Okay, so we'll declare victory there. Okay, based on that, what is rejection region? For which values of the standardized test statistic will we reject the null?
Plus or minus 2.262.
Yes, either side, very good. And so the way, I mean, you don't have to write it this way, I like to write it this way, because at least we know it covers everything. So everything from minus infinity to minus 2.262, and everything from 2.262 to plus infinity. Basically, anything in the tails will lead you to reject the null hypothesis of equality. So that is step 2. Step 3 then is if we have a rejection region, we need to what?
Calculate X bar and yes.
Yes. So we need the standardized test statistic to see if it's in the rejection region. X bar we found was 2.8. The mean from 2000 was 3. We calculated S to be 0.7. We know N is 10. So that's 2.8 minus 3 divided by 0.70 over the square root of 10, which is approximately minus 0.90. Oops. Is that in the rejection region? No. Okay, so our conclusion, the standardized test statistic is not in the rejection region, so we fail to reject the null. And what is our conclusion in terms of the problem?
It's not equal to 3. I have to, what's the problem? Can you say what you're looking for again, and I'll tell you.
What's the problem?
Or can you read the last couple sentences of the problem? I'll be able to tell you.
Oh, sure. Oh, okay, well, but it's in, I have uploaded it. It might be helpful to print that out. But an excellent point. Okay, so the problem was formulate the null and alternative hypotheses that can be used to determine whether the population mean earnings per share in 2001 differ from the $3 reported in 2000.
Okay.
Does that help you?
Say kind of fast, but yeah.
Form you. The null and alternative hypotheses that can be used to determine whether the population mean earnings per share in 2001 differ from the $3 reported in 2000.
And you rejected the null, which means it didn't equal to 3, so
Filter it.
it is the 3.
Is it? I'm so glad you volunteered for this, because we have to really twist the knife here. Are you sure that's the conclusion? What would concluding that the mean is 3 be in terms of a court of law? That would be the same thing as calling the defendant or giving a verdict of
Not guilty.
innocent, right?
Yeah, it's,
But that's not what's happening here. We failed to reject the null hypothesis, which means that
Guilty.
We're not saying that the mean is 3. We're saying that there is insufficient evidence to conclude that the mean is different from 3. So as as one individual who sat way in the back here on Tuesday said, the conclusion is, it's not 3. And actually that turns out to be right. A double negative in statistics actually is very different from a single negative or a positive. Again,
So there was enough evidence to fail to conclude that it's not 3? Or that
almost
it's
the other way
not
around. There is insufficient evidence to conclude that a mean is different from 3. Does everybody see the difference here? Or see why it's tricky to formulate this correctly? Well, the key is to do everything systematically. So first, be very careful about framing your hypothesis. Just make sure that you got that right. Then, the part in the middle, the mechanics, very similar to confidence intervals, most people get that right. If you can just get to the point where you conclude, the key thing to do is to remember, okay, we failed to reject. Go back, look at what we are failing to reject, right? If we did reject, you look at the alternative. But the key thing is to try to, again, put it back in the terms of the problem. So again, there is insufficient evidence to conclude that the mean earnings per share in the population of financial firms is different from the mean earnings per share of $3 in 2000. Questions on that? Yes?
Do we have to mention the 5% or the 95% in the answer?
Ideally, yes. So you might want to say, at a significance level of 1%, there is insufficient evidence to conclude, yada, yada, yada. Because if you chose a smaller significance level, 5%, well, I'm sorry, a larger significance level, 10% or 20%, then there might have been enough evidence. But there wouldn't be, which we know, because another way of doing this is to work with p-values. This is the part that's exceptionally painful, and which you therefore will not be asked too much about. But let's look at it anyway. If we look at the t-distribution, blown up rather excessively, and we look at 0.9, so this is a t with 9 degrees of freedom. What are the closest numbers you get in the table with 9 degrees of freedom?
0.8834.
Say that a little louder. 0.88, I'll round off to 3. And on the other side?
1.38.
1.383?
Yeah.
Okay. Now, since you have the table in front of you, you should also be able to tell me what is the area to the right of 1.383?
10%.
10%. Okay, good. Now, let's instead look at the 0.883. How big is this area? 20%. Now, finally, and for this part, getting it in black, we're looking at this area. And I don't want a number, I want to know what it represents. So if we go over here, remember we got a standardized test statistic of minus 0.9. So this area and this area both represent something we've talked about. Or the total area here, green shaded, represents what? No, alpha is everything to the right and of 2.262 and left of minus 2.262.
So beta.
What's that?
Is it beta?
Beta is the probability under the distribution solid for an alternative hypothesis. It's the probability under the validity of the null hypothesis of what? What happens in this interval?
Rejection?
What's that?
Is it rejection?
Well, no, I mean, if we get a value here, we're not rejecting the null. The key question is, if you got a number here, would that be more or less contradictory to the null hypothesis than 0.9 or minus 0.9? More, right? And if you got a value here, would it be more or less contradictory? Less. Okay, so it's the probability under the validity of the null hypothesis of getting a test statistic as contradictory or more contradictory to the null hypothesis than the one you got. What did we call it? It's P. It's the p-value. So you have half the p-value on each side. Now notice that it's the magnitude, it's the difference between 0 and the standardized test statistic that determines when something becomes as or more contradictory to the null. So a standardized test statistic of 0.91 is considered more contradictory to the null hypothesis than a test statistic of minus 0.90. So each of these represent half the p-value. And so this piece is half the p-value. Okay, now you can imagine these as overlapping, literally one on top of the other, right? You've got this one, and then you have this one, and it covers everything all the way out to plus infinity. So, which is larger? Half the p-value, which is the area from here plus infinity, or the area from 1.383 to plus infinity? Right. So half the p-value is larger than 0.10. Now do the same thing for this piece. Which is larger? Half the p-value or everything to the right of 0.883 below the curve to plus infinity? Excellent. So you have 0.20 is greater than half the p-value. Multiply across by 2, and I'm going to turn it around as well, and we end up with 0.20 is less than the p-value, and is also less than 0.40. That's all you can say using that table. If you plug in and you get some computer to give you a p-value, you'll get a much more precise number. However, if you get that inequality, and you know that alpha is 5%, could you conclude? And what would you conclude? The p-value is greater than alpha, so you
don't reject the hypothesis.
exactly. You failed to reject the null hypothesis. Right? Which is consistent with what we found here. Questions on that? Any questions at all on what we've done today? You have that saturated look, the deer in headlights thing going on now. Okay, are there any questions about the midterm? You're going to get it 1 week before it's due. It won't cover today's material. It'll be on everything after the first and before today. But remember, one thing we haven't tested on that definitely came before is the expected value of, or the value of information. So the lecture 3 PDF is up there for you to take a look at if you want. Okay, I was asked, is it going to be longer? Chances are yes, it's going to be longer than the first midterm, which covered 2 weeks of material. But I'm going to make it. I'm not trying to make it so that you're going to end up working, a week on this by any stretch. In fact, that's spring break on the exam. And I won't be putting a time on this, but I will ask you for a time estimate, just so that I can keep track of how long you're spending on it. Yes,
You had a note about an available, I can't find it right now, something that was available out on Blackboard and I couldn't find it. Info.
have you been on, part materials? Okay, lectures?
Through 8.
Three.
3 through 8. 3 through 8.
Under lecture 3, there are two different pieces. One of them is a PDF. It's a fairly large PDF.
Huh? Chapter 3.
And that is
Right,
the.
and that's what he's talking about right
Solution sketch to the problem I did on the board.
The oil field.
The oil field example, yeah. Other questions?
Yeah, have you decided about a review session?
We're still in the process. At the moment, we've got 8 or 9 people out of 100 who are saying they want it. So once we get up to a reasonable level, I think about a quarter of, at least a quarter of the students want it. So basically one class, then that's fine. I do want to see some people showing up that way. So if you do want to come, send an email saying that you are coming, and you're bound to come. Then I'll be happy to set that up. Yes.
What would be the format of the review, like?
Oh, it would be questions and answers. You can ask me what you're wondering about, and we'll talk about it.
Do you have a location on that? Is that gonna be
It
here?
would be, the location I've gotten is in Buckhead. It's right across from Lennox. What do they call it, 112 Oak or something, or yeah, I think it's 112 Oak. But you can find it on the web, the Buckhead, Perry location. It's not bad, I mean, it's similar size to this, it's just it's flat. Has everybody been there, or everybody know?
No.
Okay. It's
Know
not
where
that
Lennox
hard to
is.
find, and I think it's easier for most people to get there than up here. So I'm not unhappy with having it there. Obviously, it's not everyone's advantage.
Right across from Lennox Mall, right?
Yeah, exactly.
On top of the bucket shop.
Yeah, exactly. There we go.
That
Yes,
might give people some bearings there.
exactly.
I'm talking about the same building that's got Blue
So
Point.
my guess is we're gonna end up
So you
having
got Blue Point on the first floor?
on Sunday, the 16th.
You know that one building that's
Yeah,
got the-
that was also by request.
Oh, no.
It's
So
not that one.
apparently, it would help with avoiding a hangover. Any other questions? Have a good break.
It's,